So today we have a new problem with one more slight change. We have a peak in between two stations through which we are looking for intervisibility. Okay, so we have same stations A and B, two stations separated by 100 kilometers, and there is a peak C or P that is 40 kilometers from A and is having a height of 300 meters. Okay, so we will start with it. Okay, if this is the surface of Earth, we will call this point as A, we will call this point as B. Ground points are marked with small letters, and this is the line of sight, and this point is C, point of tangency. Okay, and suppose here is P, we will express it as small letter P. Okay, and the distance between A and B is 100 kilometers, that is capital D. AC is, we will name it as D1, this is D2, CB. A to P is D3 and P to C is D4. Okay, and we will name this as capital A. We know the position and it is 200 meters. We will take it as H1, and we will name it this one as B1 because we are not certain if suppose B1 is the accurate position of B or not. Okay, so we will name it as B1, small letter B1, and we will name it this point as P1. Okay, so now with this informations and all these values in here, with this sketch you can calculate how many values. H1 we have 200. With this H1 we can calculate D1. Using D1 you can calculate D2, D4 and D3. D3 is 40 kilometers, you know it, given in the question. Okay, and B1 you can calculate using D2, okay, and P1 you can calculate using D4. The same equations, the single equation we know about. Okay, so we will start. What is D1? D1 is equal to H1 by 0.0673 whole root, that is 200 by 0.0673 whole root. D1 is equal to 54.51 kilometers, and using that value we can calculate D2 as always 100D minus D1, that is 54.51, that is 45.49 kilometers. And with again with D1 you can calculate D4. D4 is the distance. D3 is 40 kilometers and D1 is 54.51 kilometers. So D4 will be equal to 54.51 minus D3, that is 40 kilometers. It is 14.51 kilometers. So we have D1, D2, D4. We have all the distance values, And now using the same equation you will calculate PP1 and BB1. Okay, so PP1 is equal to PP1 is this height, so we will substitute in this equation like this manner. H is equal to 0.0673 d square. H is PP1 0.0673 into D in here is D4. D4 in here is 14.51 square. Okay, clear? That is 14.14 meters. Okay, then BB1, or in this case H2. BB1 the same, H2 BB1 is equal to 0.0673 into D distance is D2. D2 is 45.49 square, that gives 139.26 meters. Okay, so we have found out all the height values and all the distance values regarding this particular sketch. Okay, so we know PP1, we know BB1 and all the distance values. Okay, then what is your next step? Now our constraint is this P. So your initial question is covering this peak of 300 meter height is A and B intervisible. So obviously this line of sight will not be possible because there is a peak in here with 300 meters, and this PP1 distance is only 14.14 meters, only 44.14 meters. The rest of the height is lying on the top of this line of sight. So obviously this line of sight will not be practical, so we are adopting a change of approach. Okay, so we are taking or measuring the actual B in here. Actual B height is 1000 meters, 1000 meters from here. So actual B will be spotted like this, 1000 meters, and this is taken as capital B. Okay, so to whether check that if A and B, actual B and actual A is visible or not, listen carefully. We will join this line of sight, the actual line of sight between A and B. So this is the actual line of sight passing from A to B. Okay, and we are checking now whether this height of line of sight at P less than or greater than 300. Okay, same concept, but instead of checking with height of line of sight at B like we did in last two problems, we are checking the same thing with P, whether the peak P, which is having height of 300 meter, is blocking this line of height which is passing through peak P. Okay, so we have joined the line and we know the distances 200 and 1000 meters, and now from this triangles we will check whether this distance, if this is P, P1, we will name it as P2, P2. So if small letter P, P2 is greater than 300 meters, So what is PP2? PP2 is not the height of peak P, it is the height of line of sight at P. The similar thing we used to name for B in the last problems. So PP2 is the height of line of sight at P. Okay. So PP2, if PP2 is greater than 300, then the peak is somewhere below P2, and hence this will be A and B will be intervisible. If peak P height of line of sight at P is less than 300, then actual P will be somewhere here, and hence A and B will be not intervisible. Okay, so you get the point. Okay, so we have estimated or calculated all the other things. Now next step is very simple. We will consider this similar triangles. Yes. First similar triangle is triangle AP1 P2. This smaller triangle AP1 P2, and triangle this bigger one AB1 B, capital B, AB1 capital B. Okay, so using these similar triangles we will just find out the height of P1 P2. Okay, so for that I will just so what we want is P1 P2, the similar side is divided by B1, and it should be equal to, we will take the base measurement is same as this measurement. Okay, so AP1, we know what AP1 is. AP1 is D3, 40 kilometers, divided by AB or AB1, that is 100 kilometers. Okay, so what is P1 P2 is equal to AP1 is 40 kilometers divided by 100 AB1 multiplied with what is BB1. BB1 is equal to B, capital B small b is 1000 meters minus H2, that is 139.26 meters. BB1 is equal to 850.13 meters. Okay, we just need BB1, this distance or height. Okay, we have already calculated BB1, small letter BB1 as H2 in the first phase. So using that value 139.26, we found out BB1, because we know the total height of B is 100 meters. So we have BB1 850.13. So P1 P2 is 344.29 meters. Okay, and this is not the height we are looking for, it is just P1 P2. So the height of line of sight at P is equal to P1 P2, we just found out, plus PP1. we want the height from the ground itself. Okay, so that is 344.29 plus 14.14, that is equal to 358.34 meters. That is P2. So that is the height of line of sight at P. So as you know, the P height is just 300. The height of line of sight is 358.34. Hence, obviously, capital P will be somewhere below the line of sight, and hence A and B are intervisible, as 358.34 is greater than 300 meters height of peak. Okay, so that is the inference of our first question. And next question we move on to, if whether this height is 360 meters. What if the height of peak is raised to 360 from 300? Then what will be the, or what should be the increase of height that should be needed in order to make A and B again visible? The height of scaffolding that you need at B, so that you can overcome the height of 360 meters. Obviously, because height of line of sight is 358.34 meter right now. So obviously, if the height is raised to 360, it will be, A and B will be not intervisible. So if the height is elevated to 360 meters, what should be the height of scaffolding to which B should be raised in order to become both intervisible? Okay, so we'll move on to that. Okay, so for that, we have a vertical peak in here, and now the height as 360 meters. And now we are drawing an imaginary line joining A and B, and we are assuming that this line clears 360 meters or the peak. Okay, and we name it as B2. Okay, and hence B2 will be height of scaffolding, our answer, final answer. Okay, so you have to calculate B2, and what will be, you name it as P3 or capital P. What will be small letter p, capital P? That will be 360 meter as given in the question, and also you are adding a 2 meter clearance. That's arbitrary. You can add 3 meter, 1 meter, any value you can add. So 262 meters is the height of peak P from the ground that should be cleared by the line of height AB2. Okay, so we will start. Again we are taking two similar triangles, and the similar triangles are A P2 capital P, triangle A P2 capital P, and bigger one A capital B B2, triangle A capital B B2. Okay, then these two triangles as we took the bottom one. Okay, so ignore the bottom one, just take the top triangles, top two triangles. In here, what do we want to find out? B B2, it is the height of scaffolding. B B2 divided by P2 capital P, this height, that should be equal to total distance 100 minus base distance of the small triangle 40. Okay, so what is this P2P? P2P is total P to P is 362 meters minus P1 is 14.14 minus P1 P2 is 344.29, and you will get it as 3.66 meters. Okay, so substitute B2 is equal to 100 by 40 into 3.66. Okay, that is equal to 9.51 meters, approximately 10 meters. So height of scaffolding at B is equal to 10 meters. So if you provide 10 meter height in here, you can overcome the height of 360 meters at peak P. Okay, so I hope you understood. This can be the hardest one that could come in this topic, intervisibility. So understand this. We just calculated all the values regarding the initial sketch. That part is over. Keep those values. Then we consider a triangle, and using similar triangles, these two similar triangles, we calculated P1 P2. Then using that we found answer for the first part of question, and then with the second part of question, with this similar two triangles, we calculated the height of scaffolding. That's it. Very simple question. You just need to understand clearly. Okay, thank you.